You know that cup of coffee in your hand? It's so much more than just a morning kickstart. It's a chemical masterpiece. Seriously, it's a whole universe of molecules, all born from a single bean. So let's dive in and see what's really going on inside your mug.
And just to give you a sense of the scale we're dealing with, scientists have found over 1,000 different chemical compounds in coffee. That makes it one of the most chemically complex things we eat or drink every single day. It's wild.
So that's the big question, right? How in the world do we get from this hard, green little seed to the rich, aromatic drink that we all know and, well, most of us love? It's a pretty fascinating journey of transformation, and it all starts with the raw material.
Everything begins right here with the humble green coffee bean. Before it even gets near the heat of a roaster, it's already just packed with chemical potential, a bunch of ingredients just waiting for the recipe to begin.
Think of this unroasted bean as a kind of chemical blueprint. Most of it is carbohydrates, sugars and fibers. Then you've got a good chunk of lipids, which are fats, and some proteins. But the two we really need to keep our eye on are the chlorogenic acids and, of course, caffeine. They are the main characters in this whole story.
And yet, not all beans are created equal. The two big players, Arabica and Robusta, have totally different starting codes, chemically speaking. Arabica, which is what most of us drink, has way more sugar and fat. That's what gives it that smoother, more aromatic flavor. Robusta, on the other hand, it packs nearly double the caffeine. That's why it has a reputation for being harsher with a much more bitter kick.
Okay, let's zoom in on that chlorogenic acid for a second. Here's the crazy part. In its raw state in the green bean, it's not actually bitter at all, but it's what we call a precursor. As we're about to see, what happens to this one compound during roasting is pretty much the main reason your coffee has that signature bitterness. All right, let's bring on the heat, the roasting process. This is where the real magic happens. And it's not just cooking. It's a series of controlled, high-temperature chemical reactions that are going to completely change the bean from the inside out.
It's this incredible cascade of events. First up, you get the Maillard reaction. That's the same process that makes your toast turn brown and delicious. Then comes caramelization, as the sugars themselves start to break down. Then you hear it, the first crack. That's water vaporizing, literally making the bean pop and double in size. And finally, you get to pyrolysis, where the bean structure just starts to fall apart, creating that final product.
Now this is so important. That incredible smell of freshly roasted coffee? You can thank that first step, the Maillard reaction. It is single-handedly responsible for creating hundreds of the volatile compounds that make up coffee's signature aroma. It's a powerhouse.
And this just shows you how complex it is. The aroma is literally a symphony of different chemical families. You've got earthy pyrazines, sweet caramel-like furands, and smoky, spicy guaiacol. But here's the kicker. Get this. Some of the most essential sulfur compounds, if you were to smell them by themselves, they smell like rotten cabbage. No joke. It's the combination of everything together that creates that magic smell we love.
Okay, let's talk bitterness, because it's time to bust a major coffee myth. As food chemist Dr. Thomas Hoffman points out, everybody blames caffeine for the bitterness, but it's only responsible for about 15% of what you taste. The real culprits, they're born during the roast. Remember that chlorogenic acid we talked about, the one that wasn't bitter? Well, heat breaks it down. In lighter roasts, it turns into something called lactones, which give a pretty pleasant, mild bitterness. But as you roast darker and hotter, those lactones break down even further into something called phenylendanes. You can think of these as a much more aggressive, harsh kind of bitterness, and they linger on your tongue. That's the secret to why dark roasts have that really intense, characteristic bitter flavor.
So we have our roasted bean. It's full of all these newly created flavors, aromas, and bitter compounds. But it's not coffee yet, is it? The final, crucial step is brewing, where we just use water to pull all that beautiful chemistry out.
Now this is a really important distinction. Unlike roasting, brewing doesn't create anything new. It's a physical process. Water is just acting as a solvent, dissolving all those soluble goodies from the coffee grounds and carrying them right into your cup. And check this out. A typical cup of filter coffee is almost entirely water. We're talking 98.5% water. All of the flavor, all of the aroma, the body, everything you experience comes from that tiny 1.5% of dissolved coffee stuff. It just goes to show you how ridiculously important the water is.
Because water isn't just water. The minerals in it play a huge role. Things like calcium and magnesium are actually great at grabbing onto those flavorful compounds and pulling them out of the grounds. Meanwhile, bicarbonates act as a buffer. They can either mellow out a coffee's bright acidity, or if there aren't enough of them, make it taste really sour.
Your water is the final, critical ingredient in the whole process.
So let's bring this all home. With this chemical roadmap in our heads, we can actually decode the entire journey right from the farm all the way to that cup in your hand.
So here it is, the whole journey. We start with a green bean, just packed with raw potential. Roasting forges hundreds of new compounds through these intense chemical reactions. Grinding just gives us more surface area. And finally, brewing uses water to carefully pull out a select few of those compounds to create that delicate, beautiful balance of sweetness, acidity, and bitterness in our cup. Every single step is a critical transformation.
And for one last fascinating thought, the whole experience might actually begin before you even take a single sip. Some studies have shown that just smelling coffee can actually alter gene activity in the brain in a way that helps reduce stress. So that morning aroma, it might be doing more than just waking you up.
So, the next time you brew a cup, just take a second, really inhale that complex aroma, and then take a sip. You're not just drinking coffee, you are experiencing a literal symphony of chemistry.